Hello everyone, welcome to Equal To, and this is the 9th episode of our polynomials playlist, and we are starting this episode with a theorem called factor theorem. Okay, so let me just state the theorem first. So what the theorem says is, if there is a polynomial p of x, let's just make this brush a bit bigger. Okay, so let us just say we have a polynomial p of x, okay, and this polynomial should have a degree that is greater than or equal to 1. Okay, so basically means it's a valid polynomial, right? If you say a polynomial with x power 0, it's just what? 1, right? The value just equals 1. So it should be a valid polynomial, and also not negative powers, right? So x power uh, minus 1 by 2, so not those sort of things. Okay, so degree greater than or equal to 1 for this kind of polynomial. If you find a number, or if you say x minus a is a factor, if you say x minus a is a factor of p of x, then p of a is equal to 0. Okay, so this is the theorem. It says that if x minus a is a factor of p of x, then p of a is equal to 0. This is what factor theorem says. And the second point of factor theorems, this is the first point, and the second point is it's just the reverse. If p of a is equal to 0, then x minus a is a factor. Basically the reverse, right? If x minus a is a factor, then p of a is equal to 0. If p of a is equal to 0, then x minus a is a factor of the polynomial p of x. So that is what basically factor theorem says. Okay, so I hope you are clear with this. Now moving on to the example portion, right? We will be solving a couple of examples in this video, right? So here is example number 6. Okay, so let me just read the question out for you first. Examine whether x plus 2 is a factor of x cube minus 3x squared plus 5x plus 6 and of 2x plus 4. Okay, so basically we have been given two polynomials, right? One is x cube plus 3x squared plus 5x plus 6, and the other one is 2x plus 4. Okay, so let me just write the first polynomial out here, x cube plus 3x squared plus 5x plus 6. Okay, so this is the first polynomial, and from factor theorem we know that if x minus a is a factor, then p of a is equal to 0, right? So what you are going to assume is that you are going to consider x plus 2 as a factor. Okay, x plus 2 as a factor. If x plus 2 has to be a factor, then p of minus 2 should be 0, right? If x plus 2 is a factor, then p of minus 2 should be 0, because that is what factor theorem says, right? X minus a, if you consider x plus 2 as the form of x minus a, then the value of a is equal to minus 2, right? Because minus a is equal to 2, so a equals minus 2. So that is what we have basically done here. So if x plus 2 is a factor, then p of minus 2 should be 0, right? And we have to check if x plus 2 is a factor. So what we are going to do is you are going to find the value of p of minus 2. Okay, p of minus 2. If p of minus 2 is 0, then like that is basically the second point of factor theorem, right? If p of minus 2 is 0, then you can say that x plus 2 is in fact a factor of this polynomial. Okay, so let us just substitute the value of minus 2 in this polynomial here. So minus 2 cube plus 3 into minus 2 squared plus 5 into minus 2 plus 6. Okay, so P of minus 2 is equal to minus 2 cube is minus 8 plus 3 into minus 2 squared is 4. 5 into minus 2 is minus 10 plus 6. So that is minus 8 plus 3 times 4 is 12 minus 10 plus 6. Okay, so if you just add this, let us just add the negative terms first. So that is minus 18 because minus 8 and minus 10, and the positive terms 12 plus 6, that gives you 18. So minus 18 plus 18, that turns out to 0. So P of minus 2 is equal to 0. So you can say that x plus 2 is a factor of P of x. Okay, with factor theorem you can tell that x plus 2 is a factor of P of x. Okay, in this case this is P of x, right? This is what we assume to be P of x. Now you can do the same thing for the second polynomial here as well, which is 2x plus 4. The process is very same. P of x is equal to 2x plus 4, and let me just rewrite this x. It looks a lot like the multiplication sign. Okay, 2x plus 4. Okay, so what we are going to do, we are going to do the same process. We are going to find P of minus 2. So P of minus 2 is equal to 2 into minus 2 plus 4. So minus 2 times 2 is minus 4, and we have plus 4 here, that comes out to 0. So P of minus 2 is equal to 0 in this case as well. So x plus 2 is also a factor of x plus 4, and if you observe, you can find this even without calculation, because 2 into x plus 2 is 2x plus 4, right? So it obviously is a factor. So that is a no-brainer thing, but technically you can also do it this way. Okay, so that is it for this example. Moving on to the next example that also uses the factor theorem. Okay, example 7, let me just read the question first. Find the value of k if x minus 1 is a factor of 4x cube plus 3x squared minus 4x plus k. Okay, so you have been given that x minus 1 is a factor. So x minus 1 is a factor that has been given in the question itself. So with that, what you can infer is P of 1 is equal to 0. Okay, not P of minus 1, P of 1 is equal to 0, because we know if x minus a is a factor, then P of a is equal to 0. Okay, so be careful with the signs, you can make a lot of mistakes from there. Okay, so if x minus 1 is a factor, it just means that P of 1 is a P of 1's value is 0, right? So we are just going to substitute the value of 1 here in this expression, and you are going to equate that to 0, and you are going to try to find the value of k. Okay, so 4 into 1 cube plus 3 into 1 squared minus 4 into 1 plus k. Okay, and we know P of 1 should be 0, right? Because x minus 1 is a factor, in fact, that has been given in the question itself. So 4 into 1 plus 3 into 1 minus 4 into 1, which is 4, plus k is equal to 0. You can write that automatically because we know that x minus 1 is a factor. So 4 times 1 is 4, 3 times 1 is 3, minus 4 times 1 is, that has already been calculated. Okay, so equal to 0. These 4's get cancelled, and x is equal to minus 3. Okay, so that is the answer to this question. So the value of x here is minus 3. How did we arrive at that conclusion? Because they have given the question that x minus 1 is a factor to this polynomial. With that, we arrived at a conclusion that P of 1 is equal to 0 based on factor theorem. And since P of 1 is equal to 0, you are just going to apply the value of 1 in place of x in this equation, and you are going to equate that to 0. With that, you can easily find the value of k. So that is it for this example. So we have learned what factor theorem is, and we have solved a couple of questions with factor theorem. I hope you understood this. If you have any questions, please feel free to put them in the comments. I'll get back to you as soon as possible. Thank you so much for watching this video. See you in the next video. Bye for now.